So dear students, now let me discuss about motion of car along concave and convex bridge. Okay, so let me draw a bridge like this. So let me show these two things, concave and convex bridge consecutively. Okay, so there is hardly these kinds of road are there, but let me assume that the two cases I can discuss simultaneously. Okay, so this is this is the convex surface and this is the convex portion of the bridge and this is the concave portion of the bridge. So let me suppose that let me for simplicity let me suppose that the radius of both the path will be same. Okay, so let me suppose that the car is here and also car is here. So what are the forces that will be acting here? One is mg along downward direction and normal direction in here, and I am using the notation also same notation. Okay, and here is mg and here is n. But now let me solve the problem on non-inertial frame. So let me use pseudo force, so the understanding will be better. So here the outer direction of this circle, so along this direction there is a center, so the outer direction is along this direction, so the centrifugal force will be mv square by r. But here the outer direction is this, so the centrifugal force will be mv square by r. So what is the balancing condition? So for concave, first let me discuss for convex. Okay, for convex bridge what is happening, you can see n plus mv square by r, n plus mv square by r is equal to mg, so n is equal to mg minus mv square by r. So this is the relation, this is the normal reaction. But here you can see for concave bridge, for concave situation, n is equal to mv square by r plus mg. Okay, so what is happening if you analyze these two situation? So for this case at this location, what will happen? If velocity will increase, then mg minus mv square by r will decrease, because mg will be fixed. So as soon as velocity will increase, mv square will increase, so the normal reaction will decrease, and obviously we will get a particular velocity for which n is equal to 0. So when n is equal to 0, that means there is no contact, the car is no contact with the surface. Okay, so for n is equal to 0, the velocity will be mg minus, let me take it as v dash, so mv dash square by r, so equal to 0. That means g is equal to v dash square by r, so it means v dash will be root gr. So from this, for the convex case, you can see the velocity should be less than this. So for safely cross the bridge, the car should have velocity v dash less than root gr. Okay, if velocity exceeds or if velocity will be equal to gr, then n will be 0, then the car will be contactless from this surface. Okay, so the accident should occur. But here you can see there is no chance of that thing, that if velocity will increase, normal direction will increase, there is no chance to be n is equal to 0. But what can be happened here, if velocity will more and more, and also the car is heavy, and if the bridge is weak, then it can happen, then due to the huge forces, that is mv square by r plus mg downward forces, the bridge can be break. Okay, so that is the different case, that is the rare case you can say, because always the bridge was so strong that one car cannot break the bridge by increasing its velocity. Okay, so that is not the case actually, but most of times this case will arise, that when the normal reaction will be 0, then v dash is equal to root gr. That means to cross the bridge safely, the car should have velocity less than this. Okay.